to class for Wednesday. My dear friends, it is time to start a new section. 5.6 Indeterminate Forms and L'Hopital's rule. I am sure that you will enjoy this lesson again. So we are starting with indeterminate forms. So you heard this before. 0 over 0 or infinite over infinity are some kinds of indeterminate form. And we will see that actually with these indeterminate forms, we have a very nice tool, which is L'Hopital rule. We can solve our questions. My dear friends, look at the technical detail, like saying that suppose that f and g are differentiable and g prime is not equals to 0 on an interval R that contains C except possibly at C. Suppose that, look at this limit. So let's say we are trying to solve one question, x goes to C, okay? And you have like this fraction, f of x over g of x. And when you substitute this, you change x with C, and you look at, oh, what you get, 0 over 0, or infinite over infinity, or infinite over minus infinity, or minus infinite over infinity, or minus infinite over minus infinity. Let's say you have this kind of situation. Actually, can you see that 1, 2, 3, 4 situation is always infinity guys are coming up. This infinite over infinity is the general word for these 4 different categories. Okay, so when I say this, so one of them is happening. So if there is a situation you faced like that, then the L'Hopital rule says, don't worry, you can use L'Hopital. And how it works? So this limit now equals to what? Limit x goes to C. Now look, listen me very carefully, my friend. You are taking, so this is numerator, okay? You are taking the derivative of numerator. That's it. F prime x is here in the numerator. And in the denominator, you write derivative of g. Okay? Now, in here, I write a star here. Here, provided that the limit on the right side exists or infinity or minus infinity. That means after you use this L'Hopital rule doing these operations, the limit should give you some number, or it should be infinity or minus infinity. Okay? Now, here, as you see, we use the L'Hopital rule in these 2 situations, 0 over 0 or infinite over infinity. Now, L'Hopital's rule is also valid for one-sided limits and for limit at infinity or minus infinity. That is, x goes to C in star, this one, can be replaced by x goes to C from right, x goes to C from left, x goes to infinity or x goes to minus infinity. What I mean that in here, maybe x doesn't go to C, but x can goes to C from right or left, or x can goes to infinity or minus infinity. Again, you can use this rule. And I am sure that you are very looking for examples. Here is one example for you. Example 1. My friend, as you realize that this time I started my lesson from the PDF. This is what I think it will be better for you. But of course, at some points, I will go to the PowerPoints, which means to your book actually, and solve the questions from that. Now, look at this question. So, indeterminate form 0 over 0. Then how you are using L'Hopital's rule? My dear friend, if you substitute this, ln 1 over 0 gives you which indeterminate form? ln 1 is what?
0.
Oh my God, you are perfect. Okay. Then you have indeterminate form. Sorry, anything with me? I hear some voices. Okay. Anyway, now, my friend, you will use L'Hopital rule Look, limit x goes to 1. Take derivative of ln. Take derivative of x minus 1. This is equals to limit x goes to 1, 1 over x over 1, which is 1. The answer is 1, my friend. Any question? You okay, my friend?
It's okay, sir.
Yes, sir.
My friend, I just want to tell something. Some students do this mistake. Beforehand, I want to stop this mistake. I'm not saying that you will do, but maybe some of you. You are taking derivative of numerator and denominator separately. You are not taking the derivative of all this fraction. Because the rule says that you should take derivatives separately. Okay, I think you understand what I mean. My dear friend, again, L'Hopital rule can be used only in the cases 0 over 0 or infinite over infinity. And this has 4 different categories like this ones I am showing with the cursor. Okay, now let's continue. Look, this equation, infinite over infinity. Yes. Now, this is 2x e to the power x. If x goes to infinity, can you see that this time we have x goes to infinity? So this kind of. Now, this is infinity over infinity, my friend. Because e to the power x when x goes to infinity goes to infinity. Now, what we will do? Just use the L'Hopital rule. Derivative of 2x and derivative of e to the power x. As you see, it's written here. Limit, the same limit. Now, the result is in here what? 2 over e to the power x. X goes to infinity means that this guy in the denominator goes to where? Infinity. Number over infinity will go to where? 0. The answer is 0, my friend. Are you okay?
Sir,
Yes.
can you say what's the derivative of e to the power of x?
Oh, okay. My friend, this is the most easy derivative. E to the power x, the function, the derivative of e to the power x is just the same. E to the power x. We learned this in the previous weeks. Okay, my friend?
Okay, sir.
Thank you. Now you understand what is the derivative of this. Perfect. My dear friends, I think these 2 questions are okay. Now I have a surprise for you. Look, x goes to 0, x minus sine x over x to the power 3. This is of course over 0, my friend. Now, so why are you waiting? Apply the L'Hopital rule. And we started. Look, limit goes to x. Limit where to go? X goes to 0. Okay, applying. I am applying here. X goes to 0, my friend. Taking the derivative of numerator. Taking the derivative of denominator. Now, what are these? 1 minus cos x. 3 times x to the power 2. I guess you are okay with these derivatives. We learned this maybe last week. Now, what is cos 0? Do you know what is cos 0, my friend? Who wants to say?
1.
Cos 0 is what? Who wants to say?
It's 1, I
It's
think.
1.
Perfect. Correct answer. That's brilliant. So, but this makes what? 1 minus 1, 0. This goes to 0. What happened, my friend? Can you see what happened?
Indeterminate.
Yes. We use the L'Hopital, but we have a big surprise. It's again in determinate form. What we will do, my friend? What shall we do? Any idea?
Take the derivative one more time.
Yes, you are perfect. Apply L'Hopital rule again. Why are you waiting? Let's apply again. See? And we are applying again, my friend. So taking the derivative of this and derivative of the denominator. So what happens? Sine x over 6x. Okay, send x to 0. What happened, my friend? Zero over 0. What is this? What is this, my friend? What is this? Is this the answer?
Yes, Hoca.
No, this is not the final answer. We should go on. This is indeterminate form. What shall I do? Who wants to help me?
Apply again.
Oh my God, you are perfect. Brilliant, brilliant. Now we apply the L'Hopital again, my friend. And what happens? Cos x over 6. Send the x to 0 and the final answer. What do you think? Full of surprise, isn't it? But don't surprise. So what does this mean? That you can apply L'Hopital again and again, my friend. Do you understand the idea here?
Yes, sir.
So as long as you have the 0 over 0 and infinity over infinity, you can directly apply L'Hopital. This is friend of you. He helps you to solve the questions. Okay, we had nice experiences. My dear friend, we have other cases I would like to share with you. But before that, let's have a look at our PowerPoint slides. In here, I will also upload this. It gives some information. I'm just passing this, okay? It tells you what is indeterminate form and so on. And then he wrote what we already see in some other technical ways. And then there is one question here. So basically, this is an example for 0 over 0. So if you send x to 0, what happens here? What is the e to the power 2x says us?
Is it the same?
What do you mean with the same?
Is it 2 times it?
No. You are not taking derivative yet.
0 over
It will
0.
be 0 over 0.
Yeah. 0 over 0. So e to the power 0 is
1. E to the power 0 is 1.
Yeah, you are very good. 1 minus 1, 0. This is also 0. 0 over
Yes.
0 is what? Indeterminate form.
Yes.
Okay. Now, what to do? What shall we do, my friend?
Hospital's rule.
Derivate.
Okay. You are perfect. I will do this. Sorry. Now, okay, this is just beginning. Okay. Now we are doing. So derivative of numerator, derivative of denominator. Okay. Now, derivative of numerator is what? Now you are using chain rule here. 2 times e to the power 2x over 1.
Yes.
Okay, and if you send x to 0, what is the answer?
2 over 1 equal to.
Perfect. So we have the answer. Is everything okay?
Yes.
Okay. Now, let me check. Yeah, this one similar example. This goes to where? Infinity over infinity. You use the chain rule. Can you see that? Derivative of ln x is 1 over x. Derivative of x is 1. So after all, this turns to this form. And this is equals to 0. Are you okay?
It's okay, sir.
You are perfect. My friend, now I'm stopping here. I'm going back to the PDF. Okay, now we are continuing with other indeterminate form. So, my friend, sometimes when we are checking the limit, we may have 0 times infinity or 0 times minus infinity indeterminate forms. In this case, what to do? Look, in this case, for example, what's happening? You have a limit x goes to 0, f of x times g of x. Okay, so this is the start, this limit. Let's say you have like that, like this guy is gives you 0, this limit of f of x. The limit of g of x when x goes to 0 is infinity or minus infinity. We deal with this indeterminate form by writing this one as limit f of x is equals to limit of f of x over 1 over gx, or limit, right, so this limit f of x g of x when x goes to c, we can write this like that. Limit x goes to c goes to g of x over 1 over f of x. Now, this is maybe in the beginning you may be quite confused, I don't know, but this is very easy. Can you see that? Like, tell me 2 number, please. Who wants to say? Tell me 2 number which is not 0.
2 and 1.
Okay. 2 times 1. Okay, can you say not 1, another number? It's better. Let's say 3. 2 times 3, okay? You can write 2 times 3 in many ways. One of them is like that. 2 here, 1 over 3. Are you agree with me? Yes?
Yeah, sir. It's clear.
Yeah, you can also write this 3 over 1 over 2. So, whatever idea here is, the idea is the same here. So, and why we are doing this, I will tell you now. So, if you have 0 times infinity or 0 times minus infinity, you can rewrite this limit in this form. So, you can fix f of x and write the denominator as 1 over g of x. Okay, like this one. Or you can fix the g of x in the numerator. Okay, and write the f of x as 1 over f of x. If you are doing this, this converts the limit star into 0 over 0 or infinite over infinite forms, so that we can use L'Hopital rule. Because maybe you are asking to me, teacher, why don't we use L'Hopital at here? We cannot use, my friend, I told you before, L'Hopital rule you can only apply in 2 cases, 0 over 0 and infinite over infinity. And infinite over infinity has 4 different view, like these kinds, 1, 2, 3, 4 different cases for this one. Do you understand? So what we are doing, this is a technique. If you have this kind of indeterminate form, you rewrite this in this form or in this form, and then you can able to use L'Hopital rule. So let's do examples and understand this technique. Look at this. ln x times x. Now, I draw the ln x graph. X goes to 0 from right. ln x goes to where? Minus infinity. X goes to 0. So 0 times minus infinity indeterminate form. This is one of them, isn't it? Now, we cannot use L'Hopital, but we can use a clever trick, which is just I told you. So now, listen me carefully here. You can have 2 choices, like you can do this one or this one. Here, I will choose this fixing ln x in the numerator and playing with this guy. So in general, what I suggest you, if you have ln and algebraic guys like x, x square, and so on, it will be better to make the ln x to fix in the numerator and write these guys in the denominator, because then the calculations will come up more easy. Now, so I write instead of this like that. Now, can you see that the indeterminate form 0 times minus infinity immediately turn to this form? This goes to minus infinity because x goes to 0. This goes to infinity. So this form turns to this term. Now I am ready to use L'Hopital's rule. Firstly, did you understand this idea?
Yeah.
You are very good. Now apply L'Hopital. Derivative of this and derivative of this. Derivative of this 1 over x, derivative of this minus 1 over x square. Now this x comes to here. This x square goes to here. Minus you can keep in numerator or denominator, it doesn't matter. And this is equals to this, and this is equals to 0. Do you understand?
Yes.
So just a quick note. If you did this, ln x in this form, it will be not that easy. It is still manageable, but I think not a good idea. So what is the other way? X over 1 over x. So you need to take the derivative of this, but then derivative of x is 1, but sorry, where is ln x? Sorry. 1 over ln x I should write. I write mistakenly. Come on, computer. Okay, I am writing here. So x over 1 over ln x. But you know, derivative of x is okay, but 1 over ln x, how you will do? You should change this to ln x to the power minus 1, and you should use chain rule, and so on. Do you understand? It will be a little more difficult. Do you understand, my friend?
Excuse me, sir. In the previous step, you just flipped 1 over x from the numerator to the denominator, yes?
Yes.
Okay.
I am saying that alternatively you can do like that. But now when you are taking derivative, okay, derivative of x is 1, but then you should take the derivative of 1 over ln x. Then you should change this 1 over ln x like ln x to the power minus 1, and then use the chain rule and so on. So as you see that it will take a little more work. And if you also don't know the chain rule, you cannot solve this. Here, without chain rule, we solve the question. Do you understand?
Yes.
Second way of writing. But it is, I will not go to details, but I am showing you how also you can write. Okay, you are very good student. Let's continue. Now look at this question. Here, e to the power minus x root x. If you look at here, as you see, this is equals to saying that 1 over e to the power x, x goes to infinity, 1 over infinity goes to 0. This is infinity. So that means that you have 0 times infinity in determinant form. So this is 3 star. You write this 3 star. Now, okay, my friend. Now, in the actually, so we have some e guy and root guy, but you know, the question itself is actually pointing you what to do. Can you see this minus x? then you can just take this e to the denominator, isn't it? You can write this like that. And we know that derivative of e to the power x is just the same. And doing that, this form turns to infinity over infinity. And you use the L'Hopital, so what happens? 1 over 2 root x over e to the power x, which is this. X goes to infinity, also infinity. Infinity times infinity is also going infinity. Then the answer is 0. Any question? Are you okay?
Yes,
Yes, yes,
Yeah,
sir.
yeah, teacher.
Okay, perfect. Okay, in here I just wrote, sometimes students were asking me why the derivative of root x is like that, so this is the reason, but I'm sure all of you know this. Okay, now, okay, we have another case, but let us look at the PowerPoint and see if we have related questions or the same. So if you look at here, okay, I think this is the same, isn't it? Yeah. So the same question is solved here. So I would just pass this one. Okay. So I'm going back to PDF. Okay. My friend, in the tutorial, you will have different type of questions. I am here giving you the idea, the main things. There can be lots of different questions, but you are all the time using the same idea. Now, we have another indeterminate form. It is about infinite minus infinity. So infinite minus infinity is an indeterminate form. Okay? These are not real numbers. Infinite minus infinity. Now, evaluate secant x minus tan x. Now, in this question, your trigonometric knowledge should be good. Okay, so what is going on here? So evaluate limit secant x minus tan x. My friend, when you send x to pi over 2 from left, look, I draw it for you. Basically, secant x is equals to 1 over cos x and tan x is equals to sin x cos x. Now, this gives you infinite minus infinity. Because cos pi over 2 is 0. Everyone knows that cos pi over 2 is 0. This means 90 degree. Do you remember?
Yes.
Now 1 over, because secant x is 1 over cos x. So 1 over 0 infinity. Minus, now in here, if you are going to pi over 2 from left, it goes to infinity. So this is the reason you have infinity minus infinity. Okay. We cannot use L'Hopital at that moment. We need to do something. So if you have specifically actually this trigonometric guys in the question, what you can do is you can try to rewrite this. Try to see if this has a fractional format. So see secant x has a form like 1 over cos, tan has the form sin x over cos. So instead of this, I just write what they are. I didn't do anything. See, I just rewrite this. Now I'm just doing this calculation. We have actually common denominator. So this is equals to this one. Now this gives us sin pi over 2 is what? Anyone knows? Who wants to say?
It's 1.
Perfect. You have a very good trigonometric knowledge, my friend. You are very good. Look.
Sir, it's written there.
Oh, is it? Oh my God, I didn't. But I am sure you didn't take copy, isn't it?
Yeah, of course.
You already know it, don't you?
Of course, sir.
Of course. Of course. Okay. Now, my friend, this is now 0. This is now 0. Sorry, I didn't realize actually here. But anyway, we are, yeah. Now, 0 over 0. Can we use now L'Hopital? Of course. So how we are using? Take the derivatives, numerator and denominator. So this is minus cos x, this is minus sin x. Now what happens if you send x to pi over 2? It will be 0. So the final answer is 0. You okay? Okay?
Okay.
Okay, now let's go back to PowerPoint. Okay, this one. Oh, not this one, sorry. Come on, where are you? It was somewhere here. I saw it, I know. Oh, here. Okay, now look. If you do this question, what will happen? ln1 was what? ln1?
0.
0.
Yes, you are correct. So you have infinite minus infinite indeterminate form. Now what you will do, these are already in fraction form. Now you just do this calculation. Now your common denominator is here, x minus 1 times ln x. So this calculation gives you x minus 1 minus ln x over x minus 1 times ln x. I suppose you all know how to do this calculation, subtraction only. Now, the important thing is what is happening after doing that. Now, so if you send x to 1 from right, can you see what is happening?
Both.
Numerator,
It will become 0, yes.
yeah, the numerator is also 0, isn't it?
Yes.
Yeah, so yeah, that means that you can use now L'Hopital's rule. So doing this trick, we turned our indeterminate form to the one of the form that you can use the L'Hopital's rule. This is the idea. So derivative of this numerator is just we are taking now yeah. Now this is 1 over x, and this is from the product rule. You get this one, x minus 1 times 1 over x plus ln x. And if you now do this, okay, just the book is doing more calculations here, like calculating 1 minus 1 over x, and in here, after the calculations, you get this one, x minus 1 over x minus 1 plus x times ln x. And then you just substitute this and see that you will have 0 over 0 again. So remember, we did one question, so you should use L'Hopital rule again. So you are using L'Hopital rule for this guy as well. Derivative of x minus 1, 1. Derivative of all these guys is what? 1 plus x times 1 over x plus ln x. If you send x to 1, this expression gives you 1 over 2, the answer. And some table things, I'm just skipping this. So the answer is 1 over 2. Do you have questions? This is the question, and the answer starts with this. These are the steps. If you do this calculation, this is 1 over x. Like this means x time x minus 1 over x. The answer of this is this x minus 1 over x. Here also similar things comes. So denominator simplify and so on. After that, this turns to this one. Okay. So just you can do this calculation yourself and see that you should get this. Except this, after that moment, when you send x to 1, you see that this is again 0 over 0. And then apply L'Hopital again and you find the final answer. Just skip this table, okay? We don't want that table. Okay?
Okay.
In this my friend, we will come back to some other forms, but at that moment, the book also says that in my PDF forms also. Now look, these guys are not indeterminate. These are determinate. So if you have a form like infinite plus infinite, this means that you are also going to positive infinity. If we have minus infinity, this is also goes to minus infinity. 0 to the infinity goes to 0. 0 to the minus infinity goes to infinity. These are not forms. These are determinate forms. Okay? So here there is one question. Just let me, I have some voices coming. Here it's showing one possible mistake sometimes student does. For example, look. In here you cannot use the L'Hopital rule because this
Sorry
is
for microphone.
no problem, but please be careful. Now here this is what? This limit 1 over infinity. Sorry, 1 over 0. The answer is infinity. Because when you are doing to do L'Hopital rule, you should have 0 over 0 or infinity over infinity, right? But in here you didn't get indeterminate form, so you cannot use L'Hopital rule here. Okay? So be careful to book just. By the way, when you apply the L'Hopital rule, maybe the answer can be resulted as infinity. Then the answer is infinity. We don't have to find all the time some numbers. This is another reality. Now, okay, I will stop here and I'll go back to PDF. See, again, I am telling here that these guys are in determinate forms. I just told you this in the PowerPoint. Now, we have some other situations. We have 3 more cases. Okay, so what are they? At least let's have some idea. So let's say they ask you one question like f of x to the power g of x is given and x goes to c. So in the first situation, if the limit of f of x is 0 and the other guy is 0, so 0 to the power 0 is an indeterminate form, okay? And the second one, this time you have infinite to the power 0. Again, this is an indeterminate form. And the other one says that maybe, so the limit of this 1 and then the limit of this plus or minus infinity, then this is also indeterminate form. Now, what you need to do if you have such a case? I would like to express to you this all possibilities. Okay. So far, are you okay? Do you have any questions?
No.
Okay. this is quite long. I think when I start, probably the break time will come. So let's have an early break, okay? Because if I start, maybe I will not finish in 4 minutes. Because I need to do this in very detailed and clear way. Okay? So shall we give a break right now?
Yeah.
Okay. Okay. See you then at 3:30. Okay?
Okay, okay.